Alright, we're going to redo some welding on these knuckle cases. So the thing's got lots of cracks in them, all over the place. So, see where I highlighted all these before. Hopefully that doesn't go past that corner. It'd be pretty rough to fix if it does. And this one over here, I went and blasted it. This is the one where I did all the welding on it there last time. So it's got cracks here. It's hard to see all the cracks right now because I blasted it, but I can see those ones for sure. You can see the weld I did pretty good. That's really bad up here. It's a lot of porosity in here. You can tell how bad the case is by looking at through here. It's really porosity, a lot of oil is coming out. It's really hard to weld. It's all crap. So, I'm not sure how much of a hole I got right there. This needs to be welded up all through here, but I know how bad that's going to be if I weld on that. It's just going to just bubble in my face. So this is all original through here, I think. I'm not sure how much this has moved over. I don't think this thing is slid out. Hopefully not. So I'm going to leave that. I think I'll do more harm than good when I try to weld that, so I'm just going to leave it. Sometimes you just got to know when to back off. Just like I don't want to keep chasing this crap through here either. So, yeah, I got good weld on that at least. So all this welding here caused this case to go this direction. And the case was blown out that way originally, so that should brought it back. When I go back and weld up all this area here, it's going to pull it back that way again a little bit. So hopefully you don't wind up with it too far out. These I can either weld the inside first or the outside first, depending on which way you want the case to go when you weld. Wherever you put the most weld is where it's going to pull the most. So I think I'm going to go ahead and weld up on the inside first, and then I'll do the outside through here. But that's a toss-up. It's 50-50. I want to do it that way. So this will need to weld up this big dimple in here where it got heating up. Doesn't feel like it's cracked through there. It's just worn from the skid plate. This one here is actually broken. It's dimpled inward. So it's actually pushed in an old spider crack through here, which you can't see right now, but could before. So this one here, I don't know if it's spider cracked. As soon as you put heat to it, you'll see if it's spider cracked or not. So it's cracked right through there. Yep. So I got to make a decision here. We also got a little bit of a crack through here. I know there's a crack coming through this motor mount, but I'm not sure how deep it is. So I think I'm going to leave it for now. Probably weld it from the inside on this one for sure. So I think I'm going to go ahead and V this out a little bit. We'll weld this one. And this one I'll probably flip over and weld it on the outside. See if it cracks any. If it doesn't, it's just going to be a fill on the outside edge. I won't do anything on the inside. I don't see any kind of a dimple in here. The crack here will open up. This crack will open up as soon as I start putting heat over here. This will open up and I'll see what it is. I'll V it out a little bit. And I'll see how much he's open up, and that determines what I weld from this side or that side first. Putting a crack at the end of a, putting a hole at the end of the crack does not stop cracks. That's myth. Doesn't do anything. Cracks right past it. It's all about how the heat and contraction of the metal. So it expands and contracts, determines what cracks do and how you weld it. So you gotta know how the weld moves around to know what you can get at the final. Because all said and done, you want this side to match that side. And that side's got a lot of cracks in it, just like this side does. Originally I wanted to bolt these together and weld them. But, I don't think that's going to help me too much. If I do want to bolt together, I got to grind this away right here. So when you bolt together, the cases stay kind of together. You just have to V it all out on the outside and weld it. So that is the only plus about this. It would keep them more equal. Yeah, it's probably better to do it that way. At least they kind of stay together. Don't really want to do it that way, but Probably the better option. I don't know. It's a toss-up. It's 50-50. No matter what, we got to split the case and weld all this other stuff anyway, so. I don't know. Definitely have to grind this stuff all out through here to be able to do that. Just got to look at the extent of the welding you got to do and just make a decision. You see how this crack goes through both sides. I know that's cracked. This one's cracked through everywhere. This is cracked on this side, but not this side. I've already welded this from the other side, so if I'm going to weld it from this side, I can heat it up pretty good here and weld it, I guess. See what happens. Yeah, it's probably best to do it that way, but like I said, it's definitely a toss-up. Yeah, I don't know. I've done it both ways. The extent of cracking on this case is excessive. I know this was pulled out quite a bit, so when I welded this, I should have pulled it back. So I guess I'll grind this off and see if the cases actually fit together. If they're kind of fit together right now, I'll probably bolt them together. If they still way off, I'll probably weld this first. At least get this weld in here. That'll pull this corner back in. And if that makes it bolt together, then I'm good with that. Then I can go and weld the rest of it. We'll see. Let's see what we get. Do a little grinding. Make a little noise. What's the worst thing to do? Screw them up? Yeah, big deal. Right. Oh, the welding rod. I'm going to use a soft welding rod on the major part of the cracking. Down in here, because it doesn't crack as much. It's less crack sensitive. Because it doesn't expand the heat as much, contract. It's more stable, plus it's softer, so it'll stretch more before it breaks stuff. When you get to the machine surface out here on the edges, we're switching over the hard rod, because hard rod machine's a lot better and it's stronger on the outside edges. It's a lot stronger than soft rod. So I'll switch over to that. So if you want to make the cases really strong, use the hard rod, but it's a lot more cracking problems. So I go back and forth. For now, I'm going to use the soft. And the soft is 40-43, hard is 50, 53, 56, I think. Yep, 53, 56. I gotta look it up. That's this one right here. 40, 43 is your soft stuff. And there's another one, it's a 56, 66, which is the military grade. It's kind of in between. It's the strongest one, but it has more of the heat. It has more of the shrinking of the soft rod. But it costs like 4 times more, so it's not more expensive. That's what this piece of rod here is, the good stuff. I'll probably use it up here when I get to the case part in this. Okay, so I guess first thing I do is grind this way and see if I can bolt these cases together. That'll be the first one. Alright, let's give that a try. Try this one here. So basically I'm just going to grind away all this metal I put on. So that's how we're going to start. Let's see, something flat. That looks flat. It's still high. Not. That's a different part. Yeah, I kept that piece of wood here for a reason. Okay. So you can see how good my welding was. See how there's no porosity anywhere? Solid aluminum. No porosity. That means I welded good. I was able to burn all the crap out of it. Let's see what happens here. Not bolting together. It's high right over here. High spot right there. See the file. Files come in handy. That did the trick. Alright, see if we bolt together. Just like a glove. If it doesn't go together. We'll make it fit. Okay, we can see a little better. These are the dowel studs. See, this is not a dowel stud, it's straight size all the way up. So there's that one. This one's a fat one. So the step gets bigger right there. So this is bigger than this. If you look at it, maybe we'll see the difference. These two lower ones down here are doweling studs. So they are what lines the cases up so everything lines up. Together good. Well, we got two dowels. We got another dowel stud. It's an extra one. I'll use those. See, up over here. This one's the other third one that goes lines everything up. Right now we're mismatched right now. This one's a regular stud. It's pretty long. Got the right length. Not not line up very well. It's in there. I don't know if these are match cases or not. Yet to be determined. I'll go ahead and tighten this one up a little bit right now to pull it together. Go on the bottom. Let's see, it's supposed to be the same number. 8199. 2199. A 2? Oh, that's a 2. 2199. They said it the same. But these 99s are a little bit deeper stamping than these ones, so they might be restamped. I never believe what I see. If the stamps aren't equal depth and everything across the whole case, there's a chance it's redone. So I see something looks a little different. That tells me it's different. It's been played with. Definitely not happy with each other. They're together. Alright. Now that's the big one. Will this go through the case or not? It went through. Could have piece of aluminum as it came out though. That's okay. Something I should do. These are CAD plated restoration nuts. Should use zinc plated on this job. It's between CAD and zinc. CAD is a lot more silver, zinc is just more shiny. So when you do a restoration, you use zinc. You don't mean to use CAD. These are going to turn to garbage when I use these, so I'm going to go ahead and... Oh, these are long thread. Don't use coarse thread nuts on fine thread applications. Let's use the right ones. Most of these are grade 5 nuts, which means they got a little star next to them here. It means they're grade 5. These aren't exactly cheap nuts. Alright, I'll be right back.